Okay, we're going to get started with the second of our sessions. Welcome everyone. I'm just going to do a quick reason why we're here, and I'm going to let these gentlemen take us through the project. So since 2021, New Glasgow has been involved in a district energy project which has been named Heat New Glasgow, and you may ask why. So there were a couple of reasons. The number one, and it'll be touched on later in the presentation, is energy poverty. We live in the Atlantic provinces. We have an older housing stock. A lot of our homes are heated by oil. So there's an important relationship to the cost of owning a home or renting a home in Victor County, all of Nova Scotia, most of Atlantic provinces. So this is another option. This is an opportunity to reduce that energy poverty. There's also, with the closure of Northern Pulp, there was a supply and demand concern. There was no future supply opportunity for biomass, wood fiber, and this provides an opportunity for that as well. And I think finally, the scope of the project is a little overwhelming at first, and I probably, more than these gentlemen, even realized that, the thought of a project of this magnitude, how will we ever bring it forward? But then we are reminded of back in the early 1900s when our water supply at Forbes Lake was man-made and dug out back then. And we realized that you have to dream big and you have to, what's important is a long game, and we look at this similarly. So I'm going to turn it over to Rohan right now, and he'll take you through the first part of the presentation.
Right, so what is Heat New Glasgow? It's a district energy system using local biomass. Used to reduce carbon emissions and energy poverty, and it's built in a phased approach as shown in the figure. It's so that's the main energy plant. That's us right here in the school. It's showing right across. It's the proposed site. And it's a phased out approach. Right, so the town of New Glasgow supports community sustainability. We're committed to climate action and are a member of the Global Covenant of Mayors for Climate and Energy and Partners for Climate Protection Program. We're also a participating municipality in the Circular Cities and Regions initiative, and the town has adopted a corporate climate action plan and a community climate action plan, and this Heat New Glasgow project speaks to our community climate action plan. So this is how it aligns with that document. It's a focus area to explore this project, and it's a major mitigation potential that helps move us closer to that reduction target. So it's been mentioned that addressing energy poverty is a big reason why we are involved in this project. Energy poverty is defined as if a household is spending more than 6% of their income on their power bills, they're considered to be part of this group. They're usually disproportionately impacting seniors, renters, low-income folks, and they leads to difficult trade-offs like heat versus food. And you'll see in this map that Nova Scotia is quite high up there in the energy poverty rate. Just zooming in further to New Glasgow, and our rate jumps from that 27 to 47, so this underscores the importance of addressing energy poverty in this area. Municipalities can control local infrastructure and shape energy solutions, supporting non-profit utilities for fairer pricing, and of course tapping into grants and federal funds to lower cost. This will help keep money in the community. Right now, all the oil that's coming in is dollars leaving the community. The biomass, though, will keep the dollars local and will also generate jobs. The local energy plant is going to supply energy to homes, pulling them out of that energy poverty, reducing energy costs, increasing local spending, and supporting our local industry in the area. So the utility operating model in a combined heat and power would generate heat and electricity. The heat would be a near zero cost thanks to the power revenue, and these electricity funds will help build out the future phases of the project.
I'm going to not talk in the microphone. If people can't hear me, tell me and I'll try again. I just did a not talking bit anyway, so. I'm going to go back a couple of slides here and just talk a little bit about the network and the project to kind of, before I talk about the version. The slide that's here is from a report that was done. So I think, Nancy, at the beginning, like you mentioned, that this project started about 4 years ago, right? And so it's a collaboration between Torchlight Bioresources, so that's a firm based in Mahone Bay, Nova Scotia, and the town of Glasgow. So it's not the town of Glasgow's project, but we are a partner or a contributor to it. The image that's there is from Torchlight's report. Just to do that, so they should be here talking about this, and not us. For anybody that's heard Jamie talk before, you know that as much as I talk, you talk more. So. He's not here, so I can make fun. So talking about, as Rohan had mentioned, something like a district energy system here in Glasgow would be operated under a utility model. So that's very similar to how our water utility is operated, where the prices to consumers are regulated and the money that the utility can spend is regulated as well. I mentioned that as a talk with the utility ownership model and then how this relates to energy benefits and reduction in energy poverty in fixed pricing. So really the project could be owned in a number of different ways, and one of the reasons that we want to talk to folks here today is that an ownership model is a cooperative model. In many parts of the world, district energy systems or the energy facilities that feed the heat networks are owned by Woodlot owner cooperatives. And so as customers of the utility, you can be owners of the utility, or as suppliers to the utility, you can be a partial owner of the utility. At this stage in the work, so we're in, I think, about the third or fourth phase of some work on this, but the second major phase. And part of that is looking at this ownership structure. You can have anything from a completely municipally owned utility, like our water utility is, to something that's entirely private and for-profit. Neither of those extremes is likely to be feasible in this scenario. Project this size, approximately $500 million to put something like this together. Sounds like an astronomical amount of money, but the slide showing the construction of the dam at Forbes Lake in today's dollars was a comparable size project. So yeah, so there's a little bit there. I was even asked to come here and talk about that. Yeah, I have to put that on. I'm here to talk a little bit about the type of fiber that would be acceptable to that facility, why we would want to have markets for that fiber, and why that's important. So first, to reiterate, the design of it is looking at a facility that could use chips or roundwood delivery. So think about thinnings from silviculture treatments on your woodlot. That's fiber that can go to this facility. Residual materials from sawmill operations, like the bark that now gets ground up and sold as hog fuel, pulp chips that don't have financially viable market could go to a facility like this. Just had a conversation with a gentleman about wood products manufacturing facility and the offcuts and things from that facility. Those could go in an energy system like this. Some other sources could be construction demolition materials that now get landfilled, could get consumed in a facility like this. Key thing that want people to get is the whole notion that you can send to all species here. So it's great that you have a market for your pulpwood, all spruce, or ox, we'd love to have that, or all fir. They don't really want to buy a whole lot of poplar for pulpwood, or hemlock for pulpwood, but your woodlots have poplar and hemlock on them. And even if you have a good sawlog market for hemlock as an example, 50% of most hemlock stems are pulpy, even if you have good sawlog marking. So you need something for that to go. This is my my favorite presentation slide that some people here have probably seen me talk about before, but this is in the town of Glasgow watershed. The image that's on the right is town land. The image that's on the left is private land. And the division between them isn't where I put the pictures together, that's a property. So same site, same soil conditions, same impact. Area on town property was managed progressively over time with a number of silvicultural interventions. Area on the left was just left to nature to do what it did. Won't get into like the site history and the vegetation types and other things, but really just to point out that most folks could see that there's a benefit to doing that, to what we did here compared to this. In order to do that work, we need a market for that low-grade fiber to make the harvest and silviculture treatments economical. And if we didn't do that work and ultimately it is in the condition on the left, there's a market for that. To be
Tony, is this just after Fiona?
That's from just after Fiona. Yeah, so I'll talk about it in the next slide with the management. The area on the townland, there's about, it's been managed since the early 1960s there, so we're coming up on 70 years of consistent management on those townland lands. And then just a picture of some energy chips, just because it was already in the presentation. Last point on this slide is that an objective of something like a district energy system. So we talked a little. There was a little bit of a point there earlier that would be a combined heat and power project. So we don't necessarily have big heating loads in the summertime in Nova Scotia. Some days maybe you want to turn the furnace on, but we use power relatively consistently throughout the year. So instead of you being able to sell that low-grade fiber just in January when there's a big demand for fiber for heat load, you'd be able to sell the fiber consistently throughout the year, so there would always be a market for it. Is the point there. And because this is an infrastructure scale project, like creating a lake and having a water supply to the town, the investment in infrastructure works over a very long period of time. The energy facility is stood up. There's a market for that low-grade wood for the next 100 years in this area. So you can make plans and make investments in your property because you're supported by markets for the end result. I get asked sometimes about, well, where is all this wood going to come from? You're just going to start cutting down the forest and burning all the trees, and it's going to be horrible and awful. So we come back and we say, okay, what is the biomass sourcing? It has to come from sustainable forest operations and ecological forestry practices get thrown in a lot. The area that is shown here, this is around Forbes Lake, which is the town's water supply. Right up here at the end, there's where the water treatment plant is, and the dam that was shown in that earlier photos of construction. The land that's in green is the town, the yellow is the watershed boundary, which I'm going to tell a little more about that. But effectively that area was managed in some regard from 1920 until now for the protection of that water supply. The town-owned lands in there have been very proactively managed since the early 1960s under a number of different successive forest management agreements, and there's management ongoing there now. We manage that land base for water quality, ecosystem integrity, social acceptance, financial return, in that order. Same thing lots of woodlot owners do. You need to make some money from your woodlot. We make some money from that, but we protect all those other things in a different order. It's really just to highlight that the town has demonstrated a commitment over a very long period of time to implementing and sticking with sustainable forest management practices and want to be able to support that go forward. Here's my middle of the presentation, or past the middle of the presentation, but need to light people up. So this line here, this is a secondary watershed, primary watershed. There's a great big hill right here. There's a primary watershed that pretty obvious. The water runs in the lake and contributes to water supply for the town. People say, well, why do you have a secondary watershed? Like, water doesn't run uphill. There it does. We have in various spots in Nova Scotia these really neat geological lenses. So if you get a picture, that's Forbes Lake, and it's actually this brook, which is a tributary to McClellan's Brook that comes out just down by the highway here. But just the way the formations are under the ground there, pressure from this side, this hill range, forces this water up over top of the hill and down into the lake. So the water runs uphill for Glasgow. Put this up just to talk a little bit about this from a broader project. And we could talk for a minute about like social acceptance and things to projects like this. Put this up, the town as a partner in this project, not as the main proponent of it, but we're very committed to engagement with the broader community, with stakeholders. To do this, that's just a photo from a tour that was held about a year and a half ago now, where we had, related to this New Glasgow project, where we took a group of, I think the youngest kids who were about 5 years old, on up and went and looked at some forestry operations and talked about some of the things that folks wanted to know about where this wood would come from. And this is a photo from a harvest operation, active harvest operation in our watershed. That's a full-size John Deere retired harvester hiding there. Point being kind of that sometimes people imagine that you can't do forest management and you can't use equipment without making a big mess and things. It's how you implement something and how you use a tool, not necessarily what tool you use to do a job. So you can do good work. A lot of this material that you're seeing that's been made into a product, for this market, in lots of cases there isn't somewhere to sell that to, and there isn't an economical market to sell to you if you can't sell it. But having a district energy system with combined heat and power would allow those products to be sold with enough revenue to support the harvest of them and the development of those areas. So there's the end of the slides that we had. I think that from the first time we presented this, so I would be very careful that on camera I'd say the same things. I don't contradict myself from one presentation to the next. But this is a project that really is about long-term sustainability for New Glasgow residents, for the forest industry in the area, and for ecological sustainability. So it's an enabling project that will support further development in ecological forestry practices, that will reduce energy poverty in the community. Somebody asked in the last presentation, like, how many homes would we think would be connected to this heat network that's there? And I jokingly said, well, there's about 3,200 homes in New Glasgow, so 3,200 would be connected to the network. I'm saying that somewhat tongue-in-cheek initially, but there are scenarios where under a utility model you can have mandatory connections. You're not allowed to have a well in the town. You have to be connected to a potable water supply, as an example. Same thing with a sewer connection. If there's a sewer connection available to you, you can't put a septic field in your backyard in town. There are septic fields in town, but just no be contradicted. There are so like as this gets built out, there are opportunities for larger heat loads to connect. Lots of folks invested in heat pumps in the last few years, like particularly mini splits or ductless heat pumps. In many jurisdictions in Canada, they'll only finance those for 7 or 8 years, maximum 10. Anybody guess why they don't want to let you finance it for more than 7 years?
It'll last any longer.
It's not going to last any longer. So lots of people who bought heat pumps thinking that they were solving their heating problems, it's a temporary fix. It's better than oil, for sure today, but something like this is a long-term sustainable economic solution. The economic model that's behind it is based on the cost of heat to the consumers being equal to or less than today's cost of heating for this unit. So if you could heat your house for $100 a year with a heat pump, the economic model is based on the district energy cost would be no more than that. So, project like this, we can hand myself because people can ask questions, but this is a $500 million project. Under the ownership model scenario, you have to find a way to capture an equity portion in that, and so that's where different ownership models can come into play. So